Good morning, my dear students. We'll start this design problem here. Design of deck slab member. I think this design this is of reinforcement concrete design. Okay, as a design it is. This thing you all learnt in your previous semester, isn't it? In your previous semester, you all learnt in RCC the design by limit state method and okay, limit state method. You all compared with the working stress and all those things, isn't it? Okay, in limit state method, you are designed for RCC slabs, so the same procedure they here also we need to follow, but the change is there. For the live loads only you are taking 3 kilonewton per meter square to 5 kilonewton based on your IS 456 based on this loading conditions, and based on the load you are going to consider the live load from that. Okay, but in this design of slab for the bridges, here the this deck slab is going to have a load of the vehicles, different types of vehicles, since from your bullock cart, cars, trucks, bulldozers, all those things. So here which one is the heavier one, which one is the heaviest weight, that we need to consider. For that only we are having the different class of loadings that we have studied in our previous video lecture from the first module, isn't it? That IRC class AA tracked vehicle, IRC class AA wheeled vehicle, IRC class B vehicle, class C vehicles, and class A vehicle. So these are the different types of vehicles we have been studied, and the loading conditions also we have studied in our previous video lecture. Now in this video lecture we are going to study a design of deck slab, how to do the design of this deck slab. Only the just change from your design of slab from normal design of slab to this design of deck slab for the bridges is the IRC class loadings. That is the only change. Okay, so when different types of loadings are been applied, what will be your moments? That is your only change generally. Okay, however we'll study clearly about this problem here now. I will read out the statement here. Design of a slab member for a clear span of 7 meter, means the span of your bridge is 7 meter is the following data. Okay, span of the bridge is how much? 7 meter. Road width 7.5 meter. Road width is how much they have given? It is 7.5 meter. Width of the road how much? 7.5 meter. Parapet 0.5 meter and thickness of curve 200 mm. This is on the width side. Okay, thickness of bearing means the slab is going to rest on concrete pedestals, isn't it, or pillars. For that there is a bearing. That bearing is 500 mm. Now the type of load they have given is IRC class AA tracked and wheeled vehicle. They have told us to compare, check out with the two type of loading, that is IRC class AA tracked vehicle as well as the wheeled vehicle. Concrete is M20 grade concrete and steel is Fe415. Wearing coat means above the deck slab we are going to have some wearing coat upon that deck slab, that is of 80 mm. Okay, design the deck slab and show the reinforcement details. So these are your what details what they are given to design our bridge. So mainly thing is the span is having 7 meter and width of the carriage width of the road is 7.5 meter. Okay, the first one is to calculate the effective span. Okay, span shall be of the following. One is the center to center of the bearing and another is the clear span plus effective depth. Clear span plus effective depth. This thing you are done in your slab design. Okay, this class will be there in IRC 21 2000 from class number 305.4 page number 44. In that they have given the reference to how to calculate the effective span. One is center to center of the bearing. So what is our span is having clear span 7 meter plus bearing 0.5 by 2 on one side, 0.5 by 2 on the other side, so it will becomes 0.5. So it is 7 plus 0.5, 7.5 meter. This is center to center distance of your span of the bridge. Now the second option is the clear span plus the effective depth. So clear span is 7 meter, effective depth we are not found out, so we can find out the effective depth by a general thumb rule, that is it is the thickness of slab should be given for 1 meter 80 mm. For 1 meter we should give the thickness of slab as 80 meter. So based on 7 meter, so it should be what, 560 mm. Okay, 560 mm. So we'll consider as the 560 mm plus clear cover as 40. So total depth of your beam we should consider is 600 mm. Just this is what general consideration. What is the condition? Per meter 80 mm is the thickness of the slab. So what is the span? 7 meter. So it is 560 mm plus clear cover 40. So total it is 600 mm overall depth. So no, let us come back to this. That clear center to the clear span plus effective depth. Clear span is 7 meter. Effective depth is 0.56 meter. So it will become 7.56 meters. Correct. So in this we'll have to consider the least one. We'll have to consider least among these two. Whatever the two results you are going to compare, least one we will have to consider for our design purpose. First thing, however, we have first step what we have found out, effective span. Next we will go for dead load, bending moment time. Dead load calculation, as for the dead load what will be the bending moment and the shear forces. So dead load, we know that dead load, bending moment and a shear force. Okay, so dead load of this slab is, we know that the density of concrete is 25 and thickness of concrete is 0.56. Your effective depth, overall depth, it is 0.6 meter. So 25 into 1, so always take 1 meter for 1 meter of the length. Okay, 25 into 1 into 0.6, it is 15 kilonewton per meter. The UDL is 15 kilonewton per meter. So dead load due to the wearing coat is at 80 mm, so means 0.08 meter into, it is not made with the reinforcement, it is made with the plain cement concrete, so it takes the density as 22. So 22 into 0.08 into 1, so it is 1.76. Total dead weight will be what? 16.76. 16.76 is what your total dead weight. So 16.76. Okay, so with the help of this we'll have to find the dead load, bending moment and shear force. Okay, and we'll draw a figure here. A span of 7.5 meter. Upon that a UDL is going to be applied. The dead load, that is 16.7276. So what is your bending moment? WL square by 8. So dead load bending moment is 17.76 into 7.5 square divided by 8. So it will become 117.8 kilonewton meter. Similarly, dead load shear force it is WL by 2. So it is 62.85. This is what dead load bending moment and dead load shear forces. Clear? Now